Now hold on. Hold on. So I know one of these spaces really, really well. Okay, hold on. This sort of shows you how much bullshit this is. Take a look at these 5 spaces. Well, I know 2 of these really, really well. But there's one I know really well. They even call me the bro of that space. Okay? You see that number 40 to 80 billion? You guys can hear me, right? Yeah, I muted just so you... Oh, you could still hear the... Oh, okay, you couldn't hear the... Right, the desktop. I understand now. Okay. So, 40 to 80 billion in drug development. Let me walk through how much drug companies actually spend in drug development. Okay, so here's Eli Lilly. In 2024, Eli Lilly spent 10 billion in R&D. Okay, but I actually have something like that in here. I've always wanted to build this. This is a good excuse to build this. Okay, Lilly R&D 2024. Almost all of this revenue, I'm sorry, almost all of this cost, you guys know, you've been following the stream. What of that $10 billion in R&D expenditure that Lilly spends, how would you break that down? What parts go into that? You guys know. Yeah, 90% of it goes in clinical trials. That's right. And I'll get a better approximation of that, but we could say 50% or 90% or whatever you want, but most of it is not coming from discovery research. Discovery research, I hate to say it, it's kind of easy. We don't need that much help in discovery research, believe it or not. Okay, so here the top 3 drug companies spend 24 billion in R&D. Let's do Pfizer, and Merck, and J&J. Oh, is it Dip Wheeler? What balance are you talking about? You got to give me a better balance than that, Dip Wheeler. This thing is a shit show. Yeah, I don't think these guys understand drugs. So when they talk about AI will help with drugs or quantum will help with drugs, I'm sitting here saying, what the heck are you talking about? Spend 5 minutes in the drug industry, man. Is Merck really spending 17 billion in R&D? Damn. That seems Seems crazy. That's more than anybody. Clinical trials are, you got to pay people to do the experiments. The doctors collect all the data. The data has to be really pristine. You give it to the FDA. There can't be any mistakes in there. Okay, so it's probably about 100 billion in R&D spend in total. I'm not going to do every single drug company. There's a lot. You know, I would say 10% of that quantum could even possibly be relevant to. And it would not be like some major sea change. So you know, just off the bat, that's kind of a bit of a lie. 40 to 80 billion. Yeah, it's hard to fathom that idea. I mean, that's the R&D budget for like the 5 biggest companies. Yeah, it's all kind of nonsense. Yeah, you do have inflation. That is true. Okay. Yeah, this industry model idea is a really fun one. Let's keep listening.
When this technology gets to full maturity, this will return value this will create. If we give a couple of examples, take a computational problem, say in chemistry. That is easily going to have a positive impact in areas in energy, in areas in life science, and in areas in semiconductors. Another example, if you can do a computational optimization or a risk prediction, or even a simulation, you can have a positive impact in the financial service or in insurance. So at IBM Quantum, or at IBM in the quantum team, from day one, our strategy is to make sure as we build this technology, we work with our clients. Shown at the bottom of this slide is various industry clients who are already working on use cases so we can understand how quantum is going to impact them as we build this technology. If we zoom into our strategy, at the heart, we want to build differentiated quantum processors, quantum computers. We're going to either deploy them in client sites or deploy them in data centers. We've integrated it with OpenShift so that from the client lens, whether it's on-prem or in the data center, it works the same way. Built on top of this technology is Qiskit. This is our open source software. That is you can think of it as the quantum SDK for programming how a quantum.
Now you could use quantum to do different minimization algorithms quickly, more Monte Carlo simulations. But the reality is, one, we still have Moore's law picking up. And then two, you get very good approximations of those without exact answers that you don't really need quantum for. And preparing all that data and putting it into state in quantum is just impossible. So we're always going to use traditional computing and financials.
Computer will work. It's where the quantum developers will go and interact with these future computers. I put this bottom layer and I call this the IBM Quantum Platform. The next layer up is application software. As this technology matures, we have to embed quantum accelerators or quantum computers into accelerating application software and libraries. And we imagine in the future a marketplace with various applications that are all accelerated by quantum computers. Today, we've started and we've partnered with many startups. Actually, 5 startups are already integrated with our software, showing how they can do solutions in chemistry, optimization, and a few other different problems. And by the end of this year, we're going to double this to 10. So let's call this the second layer. The third layer is, like I said before, we really want to understand the client problems. So last year, we worked with industry partners and prototyped over 30 use cases, showing how quantum will matter for their business. And then we've also worked with integration partners where we've shown for their client how they can work with their clients to bring solutions of bring quantum computing to the solutions. So if I would give you the summary, the strategy for IBM for quantum computing is to build a platform down the bottom that is differentiated by the computing capabilities, to partner in the software space, and to partner in the server space. So now I want to zoom into the hardware. At the heart of a quantum computer is a QPU. I'm not going to teach about physics and superposition and entanglement. There's 2 parameters you should know: number of qubits and number of gates.
Okay. I'm looking at this. Interesting. Okay, so they have a interesting slide here. Okay, I don't know if you guys can see it. But basically, they're saying that, okay, the error rate... This is really bearish. Yeah, this spaghetti circle is like... One of these is Rigetti's, like, the specs they say exist, which we haven't seen yet.